Hello, everyone. Good afternoon. My name is Jessica Tyler. I'm a data scientist over at HelloFresh in the marketing realm of things. And the topic I'm going to be talking with you all today is going to be, how we at HelloFresh use geo experiments combined with causal impact in order to measure incrementality. And before I hop completely over into that, just wanted to give you a little bit of information about myself. Why not? So, as I said before, working at HelloFresh, been there about 2 years now. And because we are a multi-brand company, have become one, I also have the privilege to work on questions related to these two other lovely meal kit brands, Green Chef, as well as EveryPlate. Previously, I was working in advanced analytics, also on the marketing side at Hanes Brands Inc. So if you guys have any Hanes underwear, Champion socks in your drawer, in a way you're welcome, hopefully. And then before that, I did a little bit of a stint at Catalyst, which is a political consulting firm that maintains a large voter file, also does a lot of propensity modeling around people who vote in the United States. LinkedIn link is there, add me. And really moving on into what incrementality is. So as a marketing person, really I'm going to be talking about the topic in that context. And the way we tend to look at it is the measure of lift that advertising spend provides to our conversion rate. So typically, we kind of have this sort of situation here. Say that your marketing activity before a campaign is pretty stable. You're spending about the same amount of money. You have a little bit of a stable conversion rate. Maybe if you kind of see on the graph, the slope is sloping upward. You're growing a bit, which is good. And then you kind of have a campaign that you launch, and you really do ramp up that spend. And you also see that your conversion rates are increasing as well. What you want to figure out is what the difference between what you would have seen had you kept that spend constant is versus what you actually observe. So that's kind of your lift, and we really want to measure that. Why? So within marketing, we tend to think of a variety of channels that we have to access our customers at the different stages of really awareness all the way to conversion that people could be going through. And we kind of know that certain channels are better for certain stages than others. So for instance, when we kind of look at that upper funnel, when maybe someone hasn't necessarily heard of HelloFresh, maybe they know of the concept of meal kits, but they don't really recognize your brand. Places like TV, billboards, those sorts of upper funnel channels, you're going to be putting spend there, and probably they're going to eventually lead to a conversion, but it's going to take some time. And if you go off of traditional ways of measuring what causes conversions, like let's say you are looking in Google Analytics, and typically you use last click to decide who gets the credit for that conversion. It's probably going to come to somewhere like paid search. Once someone is more aware, it's likely that they're not going to directly type into their browser HelloFresh.com. They're going to go into Google, and they're maybe going to click on a paid search ad that says, hey, $20 off, or actually $40 off your first 2 boxes, then $20, then $10. I know that's our discount that we're offering. And they're going to eventually convert off of that. And who doesn't get the credit from that? Your TV, your billboards. So how do we kind of measure the impact of that fairly? And, when it comes to whether we do see an increase in conversions because of those activities that we have, we want to really know, and be confident, is that a result of that campaign? How do you know that it's that in particular and not something else that's going on? And even if you do see a significant increase in your conversions, how much are you even paying for it? Can you justify to your stakeholders that they should be doing more of that in the future? And so, imagine you're...
Our journey with HelloFresh about 2.5 years ago. You guys have really changed my life. We've seen some pretty big improvements. Ingredients are always fresh, simpler, easier, healthy.
Saves me a lot of time and money.
So let's say you were just chilling, catching up with SNL, a YouTube ad like that pops up on your feed. Maybe you're interested, but chances are you aren't going to interrupt, Pete Davidson and go ahead and convert right away. So it's going to be hard to measure what impact that sort of ad is going to have on who eventually converts. And, I took all these screenshots in case the video didn't work. Scary stuff. So really, when we had a situation like this, we had ads like this running, we had some YouTube activity, but we wanted to see whether ramping up spend in this channel would really be worthwhile to us. Like, is it scalable? Will it bring enough conversions to justify that extra spend? What we wanted to decide that based on is incremental cost per action. So in this case, cost per conversion. And luckily, we kind of already knew how the channel had been doing before. And simply what we wanted to decide is whether the incremental CPA that we were about to measure was above or, at the same place or below that benchmark. And if it was, then, great, let's do more of it. If not, probably, leave it alone for now or try something different later. In terms of, how we were going to set up the experiment, we wanted to look at DMAs, so geographic level, basically TV markets for people who kind of aren't as familiar with the marketing terminology. And in terms of steps, we knew that we wanted to somehow be able to assign these different DMAs to either treatment or control or, simply leave them out. And then eventually run the experiment, expose those in the treatment group to that increased ad spend, new type of ad, and then in the control, just keep things BAU. And then eventually, somehow, we have to estimate the incremental cost of the campaign. Because with YouTube, the thing is, because the cost structure is dependent on who converts, you can't just say, I know I'm going to spend an extra $250K. It's dependent on the people who are taking that action, and it's not a sure thing. So you actually have to figure out, what is that extra amount there, in addition to the incremental conversions that you're getting. It's a little bit of a complication. And it can definitely be hard. Like, let's say that instead of running an experiment, someone just rolled out this new cadre of ads. And, there are some things that you could try and do. You could simply compare the difference in conversions and spend after you started running those campaigns versus before. So that's more of a traditional method, like difference in differences. However, what that might not necessarily take care of is that there are confounding factors that might get in the way. For instance, what if during that time that you release that new string of ads, you also start offering a higher discount for your new customers? You can't necessarily say that the difference that you view in conversions and spend after versus before is because of that ad anymore. Complicated. Another thing that could happen, or another way to kind of approach this, is try and identify who saw versus didn't see the ad retroactively, and then compare conversion rates for the two and the spend between the two. But it could be hard to get that data, and also it's really hard to know how much extra you spent between the two groups. And calling back to Mike's talk, if you actually attended his about propensity score matching, it could be that there's some latent variable that's biasing people who do see the ad to be completely different and not really overlapping so much with the people who did not see the ad. So, what do we do? Well, one way that we can try and help avoid this situation is to set up a geo experiment. They're very popular. So basically it entails assigning non-overlapping geographic regions to either a treatment or control group, or simply, just leave them out. And absent of any sort of like interventions that may be happening in your pre-test period, or any underlying confounding variables that could be getting in the way, what you should be looking for is that in aggregate, your treatment and your control group should be similar in terms of both your event of interest, so in our case it was conversions, as well as just main predictors. So it could be marketing spend over time, it could be session traffic over time. So looking at those sorts of things. In terms of stages, basically geo experiments tend to break down into 3. The pre-period, what you'll want to do is choose a period of time that is long enough that you feel confident that you can gain insight into the relationship between your treatment group response variable and your control group variables. And also within your pre-period, what you don't want to do is be choosing a period of time when your business is acting, not really according to normal. So if you're ramping up for Black Friday or something like that, probably not a good period of time to be choosing to, build a pre-period kind of baseline for this sort of test, or, run a test directly after it. So just be careful with that. For the test period, what you'll want to do is, look at the volume of the events that you're interested in. Figure out whether that difference that you potentially will measure between the treatment and control group is enough to come to a conclusion about whether it's significantly different. And you also want to take into account any costs associated with the campaign, because maybe it'll take 6 weeks, but how much is that going to actually mean that your company is going to have to spend to run that sort of test? Maybe you end up having to choose more regions to put in the test group or something like this, if it's not too costly to do that. And then finally, typically if your event of interest has some sort of delay associated with it, so like in the YouTube ad, maybe people aren't going to convert right when they see it. We might want to leave an extra week or 2 to see if there's kind of a lag in that effect, and measure those extra conversions that may be coming in because of your activity. Another nice thing about having a post period or pull down period is that it can kind of be an extra check to the fact that there wasn't some sort of confounding variable that happened during your test period. So you kind of want to see just a gradual delay or decay really in that effect, rather than it just dropping to nothing once you get to that period. All right. So in terms of the actual setup, again, the first step is assigning those regions to the 2 groups. And, in terms of ensuring that those groups are similar based on your pre-period data, there are a couple of different approaches. The simpler one is just stratified random sampling. So, back to that point about confounding variables, those could be really good candidates that you want to look at in terms of building your strat on. So typically it could be like the size of your geographic areas. Like you don't necessarily want New York, LA, and Chicago to all be in the test group. Like it's not going to be good for you. That sort of thing. Another way that you could go about this is matching your markets or groups of markets based on time series modeling. So there's one kind of interesting approach that is called dynamic time warping. I'm not going to get into that right now in the interest of time and maybe questions later, but definitely check it out. And then after you've assigned your groups and kind of nailed down what those are, you're going to run your experiment. And at the end of that cool down period, if you've elected to have one, you are going to somehow have to measure the effect of your marketing intervention. Traditionally, as I kind of mentioned before, you could do difference in differences, which would kind of look like this. You just take the difference in test versus control after versus before, say that's conversion rate, do the same thing with spend. But the problem is, what if there's, a really crazy spike in one of those trends? If you just look at the mean, that's not going to be the best representation, as I'm sure we all are aware. So not always the greatest, and of course the confounders. Alternatively, what we could do is more of a causal impact approach. So this is a model that will take information about how the relationship between the treatment kind of response variable and your control group looks like, kind of models that out. And then what that allows you to do is make a prediction of what would have happened in your treatment group had it not been exposed to that extra spend. And finally, you just compare the difference between what you actually observed and what that model says would have happened, and you can get a pretty good reading on your lift. So kind of more about the model. Required inputs, you are definitely going to want your response time series. So say it's your treatment group conversions. You're also going to want a control time series to kind of build that model on. It could be control group conversions, but definitely by all means add other variables to it if they're meaningful. So maybe it could be number of sessions in the control group. Maybe that's predictive. And then eventually you use those inputs to build this Bayesian structural time series model, which kind of just takes information about what happened previously, like what that relationship looks like, and allows you to predict that counterfactual. So like what would we have observed in the treatment group in the absence of that intervention or your marketing campaign? And that difference between observed and the counterfactual is going to be your incremental effect. And kind of like the way that these results tend to get visualized is in like this set of 3 plots that I'm going to take you through. So this is kind of just the normal view where the solid black line is just the trend of your response variable. The vertical line is when that intervention started happening. And the dotted line that kind of tracks along the solid black line is what the model predicts would happen based on the information from your control variables. And as you can see, like once that intervention hits, the difference between the dotted line and the solid line really spikes a lot. And typically the next plot that you'll see is this sort of pointwise sort of representation of that view. So, I mean, ideally, when you are building your model, the pre-period should be very close to 0. Shouldn't really be any trend in the error there. Otherwise, maybe evaluate adding more variables, changing your test versus control, something like that. But this looks good. And then intervention hits immediately, it's hovering around a difference of 10. And then this is the same sort of view, except it's just cumulative over the points. And I'm just going to quickly run through how one might do this in Python. Typically, these packages are more of an R domain. The original CausalImpact package was built by the lovely people at Google, and I definitely still use it as a benchmark for results that I get in the Python packages, but this is one way to do it. So in terms of installation, super simple. The package that I use, just a pip install PyCausalImpact. And then once you have it installed, which if you're working in an Anaconda environment, I don't believe I had to install anything extra in order to get it to just completely install without issues. Then I just imported CausalImpact function from CausalImpact, as well as just some helper packages that I needed for my analysis. And then, just setting some visualization settings, suppressing warnings in case. And then, once we have that all in, just like load and examine the input data. So one thing, as I kind of hinted at before, is that in order for us to be able to determine the incremental cost per conversion, we needed to build a model on conversions as well as a model on cost. So we have a conversions data frame, just looking at the head. The key thing here is that in order to use this package and not have it break, is your response variable is going to have to be at the far left, and then followed by any control variables you have. Same thing for the cost data set. Fake data, it's fake. So moving on from there, just quickly wanted to do a visualization of the two trends together. Left axis shows the treatment group. In this case, it looks like we had fewer regions assigned to there versus the control group. But after the intervention period, it does look like, at least in this chunk, we're seeing some lift there. It's promising. Maybe. We'll find out when we build a model. In order to do that, though, we need to figure out when the pre-period is and when the test period is. And in this, I'm including the post-period, so we did have a cool down. So I just have a list of dates, and I'm going to figure out just like where they are in the set. I could have easily put it in the index, but silly me. So that's another input that you're going to eventually need to eventually run your causal impact model. So you're going to want to have a list of two dates: the start of the pre-period, end of the pre-period, start of the post-period, end of the post-period. And then we kind of get to the fun bit. Causal impact model, very simple to call. There are three required arguments. You have your data set. Here I just used two variables, your response and then control group conversions. Pre-period, the list of the two dates. Post-period, same thing. Alpha, so you can kind of use your discretion here. Basically, it'll give you the probability of accidentally rejecting your null hypothesis, basically that there was no effect of the campaign on conversions when there actually wasn't an effect. Here we decided to kind of set it to 0.1. By default, it sets to 0.05. And there are other parameters which we could talk about later as well. But in terms of once you've actually called that function, built that model, here's what you'd expect from an output. Like if we just wanted to see a quick, nice plot of the results. And basically, it's what I kind of walked us through before. Those actual observed versus predicted in a normal view, and then your point-wise estimates or of difference between actual and predicted, and then your cumulative sum of those points. And then finally, the main question is, how many incremental conversions did we get from this? Within that green box, we have that cumulative absolute sort of incremental number estimate. And because I wanted to have my alpha set to 0.1, it returns a 98% confidence interval. So we should be that degree confident that because of this campaign, the extra number of conversions that we got is somewhere between around 698 and 1,420. And that's pretty good. Looks nice. There was a causal impact according to this. We're going to want to repeat that process for the cost data. So then we can get kind of our average incremental cost per conversion estimate. And then because this package does return intervals around the estimates, you could kind of give your stakeholders a best case scenario, CAC, or a worst case scenario. So, if they're really cautious about it, that's sort of hopefully the worst, at least within 90% confidence that they could expect to happen. So that's pretty much all it takes. And, from here, it's just conclusions are that, at least at HelloFresh, and I'm sure in a lot of the businesses that you all work with, there's a lot of marketing activity going on, if it's, very consumer-centric, B2C. And it's really hard when you have all of that stuff going on to cut through the noise, so to speak, and determine whether any particular one actually had an impact. And I think that using these two techniques together, if you do have the luxury of planning for an experiment, definitely allows us at HelloFresh to answer these sorts of questions with a greater degree of confidence than a post hoc sort of analysis. Just random assignment of the geographies and having that period split really helps us to make sure that it really was because of the campaign and not just some random confounding variable that was driving that. And then the model, it just uses that previous information about how your variable of interest in your regions of interest relates to other factors that are predictive of it. And so that really gives you more of a confident estimate on what that incremental lift is. And finally, just, traditionally, yes, as I mentioned, R has been more the realm in which these things have been developed, but, Python, yay, we're getting there. And there's that Python package for CausalImpact. And, if you all know any sort of packages out there that help with the selection of markets, definitely hit me up, because I could add that to my appendix, which I'll also provide to you here. And I guess that's everything for me. Any questions? Yes.
So when you design an experiment in order of importance, what do you think is the most important, like coming up with the alpha of like 0.05 or deciding on a sample size?
Definitely, I think the sample size, so just the power analysis that goes behind, just if I want to measure this amount of increase between my treatment and my control group, how big of a sample am I going to need? How long is that going to take given what we've seen happening in our market in the past, or in the markets in the past, and how much it's going to cost? That piece of it, sort of mapping out that test period length, I think that's a big decision. When I think back to just the times when I've advised on tests, those are the questions that stakeholders, and honestly us as well, so that we can get a good measurement, are pretty concerned with.
So are there times that you have to forego a little power just to create the experiment for 2 days, for example?
Yeah. I guess in that case, maybe it would be more of a situation where you'd try a post hoc analysis, maybe with this propensity score matching technique that Mike's presentation touched upon. Also, I guess CausalImpact is a sort of package where if you didn't run an experiment, you could also throw in some control variables that map back to what you think was impacting your event of interest, and just see what happens.
Thank you.
Yes. Oh, yeah.
Or it's okay. I can speak about that.
Okay.
What is the underlying model used to being trained to generate the counterfactual? Could you talk about that a little bit? And with this framework, it sounds like maybe if you wanted to swap out that model, you could hear you say.
Yeah, so in the case of the Python package, it is some sort of a variation on Bayesian structural time series. So it's kind of taking, the observed data plus how that data trends and changes over time. And sort of those are the main components. And there's a bit of, this kink where it's like if you see that your control series is not very predictive of what's happening in the treatment, then there's this sort of random variable that will kind of play in more of a role in order to kind of compensate for the fact that your predictor isn't really doing it. So that's like the underlying model for Python. I think with the R package, it's slightly different. But definitely that is one of the main parameters that I didn't get to touch on in the presentation, is that you can switch out the model for something that you've built in-house, like if you feel like that's a better representation. Yes?
Can you tell us more about how you select the DMAs? I feel like that has a lot of influence on outcomes.
Yeah, so I think one possible way is that you kind of minimize the difference between just like the trend of conversions over time during your pre-period. And like you could use like variables just like MAPE if you're building a time series model based on what's happening in your control DMAs. The dynamic time warping is this thing where it looks not necessarily as at the very points in time and compares them straight up. But if there's a little bit of a lag in one series, but the trend overall is still quite similar, it'll choose that as a control. And I mean, I'm sorry to say, but market matching, it's an R package. I've used that in the past in order to kind of help me choose similar regions. Yes?
I know you mentioned this before, but could you talk a bit about what the improvements are compared to different businesses, and if you guys have kind of run which aspect better?
Yeah, I mean, I think like the main thing would just be like being more confident that you're taking care of your confounding variables. So, I mean, I think partially if you do select your DMAs with that knowledge and kind of domain expertise about what's happened in those markets in the past in mind, like that should reduce that risk. But I think with the modeling aspect of it and it not being just a singular point estimate, just building that counterfactual out is a bit more helpful as we've seen it. I don't think that we've necessarily done a straight comparison between the two, but at least within CausalImpact, like we've kind of checked out what the difference between the Python and R packages were returning. I believe that with Python, the interval tends to be tighter. And I think also there's this thing called time-based regression, which is more for when your set of DMAs is of a smaller size and it's supposed to be more of a controlled experiment kind of thing. Unfortunately, I believe that's also only in R. Yes?
How do you determine how long the test period is? Is it like content-based or cost-based or product-based?
I think, yeah, like definitely a combination of the cost, like for sure, just like if we know that based on the number of conversions that we tend to see with this group of DMAs versus that group, if we want to measure a 5% increase versus the control, that set of ads is going to have to run for 3 weeks and it costs, $250K or something, and that's over budget, then it's sort of tricky. But I think those main things. Others. Okay. Thank you.